Hello. The points A, 1, 5, B, 4, -1, and C, -2, -4 form a triangle ABC. Prove that this triangle is right-angled and find its area. Now, one of the things we know about any right-angled triangle, if we were to sketch it, is that this line here is perpendicular to this line. So if this is the triangle A, B, C, we know AB is perpendicular to BC. And that is one indication that it's a right-angled triangle. So what we can, our first approach is to find the gradient. We find the gradient of AB and the gradient of BC. We can then find whether it satisfies a certain condition, and then we can determine whether these two lines sides are perpendicular, and then we can go ahead and use other concepts to determine or to prove that it's right angle. So first of all, we'll find the gradient. We'll find the gradient of, which is m, of AB. So we know the coordinates here is 1, 5. At C, at B it's 4, -1, and at C it's -2, -4. So the gradient AB, which is y2 minus y1 over x2 minus x1, gives us -1 minus 5 over 4 minus 1, which is -6 over 3, which gives us -2. That's just slightly off the screen, so -6 over 3 is -2. So we know our gradient of AB is -2. Let's check the gradient of BC. So gradient is m of BC. That's y2 minus y1 over x2 minus x1 is equal to -4 minus 1 over -2 minus 4. It's -3 over -6, which gives us a half. Now, the concept we'll use here is that the product of these two gradients, gradient of AB and BC, should be equal to -1. So we'll call this AB's gradient M1 and BC's gradient M2. So M1 times M2 should be equal to -1, and we can check that as -2 times a half, which is equal to sorry, I'm off the screen. Let me just right. We have M1 times M2 is equal to should be equal to -1, and we know M1 is -2 and M2 is a half, which does give us -1. So we've proven here that AB is perpendicular to BC, so we can assume that this triangle, as it is the right angle triangle with the indication that that's 90 degrees at this point. But we can do more. We can go about finding the length of AB and BC. We could use Pythagoras' theorem and show more and produce a more convincing argument that this is a right angle triangle. We'll do that in part 2. Thanks for watching. I'm Alistair.